So today we are actually starting the family of absolute values. If you remember from the parent function transformation, the woman went on a whole talk about families and how they all looked alike. So we're going to talk about the families of absolute values. It's the absolute value function, and like she said, it has a parent. The parent is y equals the absolute value of x, and I know we've looked at this. We're just going to make sure we're ready for tomorrow. I'm going to create the parent table. So again, parents, I'm going to use -2, -1, 0, 1, and 2. Remember, x's I just get to pick. They don't come, I'm not pulling it from somewhere. I could pick -4, -5, but typically in a parent function, if you pick these 5 inputs, it's going to give you a better idea of what the parent looks like. So again, what do the absolute values mean? Absolute value is the distance from 0 So if I take this -2 and I plug it in here, the absolute value of -2, the distance from 0 that -2 is 2. The distance -1 is from 0 is 1, 0, 1, and 2. So my parent would look like this. And we expect you to be doing this on graph paper. That is the parent of absolute value. So what happens when I do these hot pink transformations on them? Well, the first thing we need to do, like we have been doing in transformations, is we are going to create the parent table. Once I have the parent table, I'm going to do the transformations. And I'm going to label the transformations first. This is an A, this is C, and this is D. And remember, A is my vertical stretch or compression, expansion or compression, whichever. So I'm going to multiply my y's by -1/2. And I'm going to get -1, -1/2, 0, -1/2, -1. Then I'm going to move to my C. And remember, I'm looking for a value where x minus 1 brings me back to these x's. And I think everyone learned in the transformation unit that what I do is I add 1 to all my c's. So I'm going to add 1 to all my x's. Sorry, add 1. Last, we're looking at the D. And the D, remember, these on the outside affect the y. This is a vertical shift up or down. This would be up 3. So I'm now going to add 3 to all of my y's. And I'm now going to graph. Here are my x's. Here are my y's. Zero, 2.5, 1, 3, 2, 2.5. Oh, wait. Sorry, guys. 1, 3. And this would be my new graph. Okay, let's talk about domain. Domain is -infinity to +infinity. Range is, remember, bottom, which would be -infinity to the top. The top of this graph is right here, so that would be 3. But since there's a point, it's a hard bracket. I'm going to use interval notation. Okay, the other thing I want to write down are the transformations. The negative reflected over the x. The -1 shifted me right 1, and the 3 shifted me up 3. Okay, let's try this one. This is my A. Nope, it's not, is it? Hope you caught that. This is my B, this is my C, and this is my D. And since we've already done these transformations, I would like you to finish this one and show this in class tomorrow completed, and we will talk about it. I want you to make sure you do domain and range and write down what the transformations would be. and I will check this in class tomorrow. So one of the things that's going to be new on this test, because this test will really only cover graphing and writing equations. So writing equations is going to be new. And I would like to tell you what the standard form of a absolute is. Y equals A, x minus h. Whoops. This is an absolute though, right? Plus k. And that should look really similar. This should look like C and D. And for some reason, they change it to H and K. They do the same exact thing. So remember, inside the parentheses, we always do the opposite math. Okay? So I want to write the equation of this, but where do I start? I start with what's called the vertex. And I know you all know what a vertex is because you've done quadratics. That is my vertex. My vertex is -5, -2. Okay? So that really, if you think about what we've been doing, is that really is a backward shift of 5 to the left and down 2. Left 5, down 2. Well, a left transformation is just my C, right? But in an absolute, it's going to be called H. So I'm going to do left 5, down 2. So we're going to talk about the H and K first. So Y equals left 5, which I know is going to be put in as a +5, down 2. It turns out that my vertex is going to be HK. So this number and this number are going to be my vertex. Okay, but remember we do the opposite math in here, so this vertex is going to be -5, -2. All right, I now need to get another random point, so I'm going to pull the point -3, 1. And I have my vertex, which is -5, -2. All right. I'm going to look at the equation that I've filled in so far. So far I've put the vertex in here. What I don't know is A. I don't know if there was a vertical stretch or a vertical expansion or compression. I don't know if it was reflected. I do know that it was shifted left 5 and down 2. But I have this point x, y. And I'm going to label this point x, y. But I'm going to do it above it. So this is x, y. And I'm going to take that x, and I'm going to plug it in here, and I'm going to take that y, and I'm going to plug it in here. And right now on your notes, over here somewhere, you should be saying plug x and y and h and k into standard form, which is this. I'm now going to take my x and my y and plug it into here. So my y is 1, my x is -3, and look what all I have left. All I have left is my a. Now I can figure out if I'm reflected, if I'm expanded, stretched, or if I'm compressed. So I'm going to solve for a. So I get 1 equals a, absolute value of 2 minus 2. Okay, remember this right here is a times the absolute value of 2. The absolute value of 2 is 2, so I have 1 equals 2a, I'm going to write it correctly, minus 2. I'm going to add 2 to both sides. I get 3 equals 2a. I'm going to divide by 2, so I get a equals 3 over 2. I now am going to complete my equation, so 3 over 2, I'm going to plug into here. Y equals 3 over 2, x plus 5 minus 2. And this is the answer to the equation. I would now like you to copy this graph down. I'm going to give you the standard form and I would like you to write the equation of this absolute value graph. We're going to be checking it tomorrow in class. Good luck.